In SSC exams, number series questions are a trap. Either you see the pattern in 10 seconds, or you burn 5 critical minutes guessing, scribbling, and crossing out math that goes nowhere. These examples come directly from Kamal Sir's practice set of high-level previous year questions. We're going to use them to see how these traps are actually built. The gap test serves as a visual framework to instantly identify which math operation to use before you even calculate a single number. Over the next 5 minutes, we will walk through 4 specific frameworks that identify patterns in under 15 seconds. Clearing the cutoff requires algorithmic pattern recognition. Once you recognize the structure, the math becomes secondary to the speed. Framework number 1 is the double difference or step form trick. This applies when the numbers in a sequence grow at a steady, manageable pace. Look at this sequence from the SSC CGL Tier 1 exam: 2, 12, 30, 56, 90. The numbers are increasing, but they aren't jumping by hundreds or thousands at a time. Step 1 is to extract the baseline gap between each number. 2 to 12 is plus 10, then plus 18, plus 26, and plus 34. Since the first layer doesn't show a clear pattern yet, we look for a difference within those differences. 10 to 18 is plus 8. 18 to 26 is plus 8. We found a hidden constant. Now we build the steps back up. Adding that constant 8 to 34 gives us 42. Add 42 to 90, and we arrive at 132. That's option A. When a steady series looks random, digging one layer deeper often reveals the constant needed to solve the problem. Framework number 2 is used when a sequence starts small but accelerates aggressively. Take a look at question 2. 4, 18, 48, 100. If we try a standard difference check here, the gaps expand from 14 to 30 to 52. The lack of a steady rhythm is a sign to stop adding and look for powers. When numbers scale this quickly, we test them against perfect cubes. If we compare these to 8, 27, 64, and 125, we see they all fall short by a very specific amount. The deficit for each term is actually the square of its position. For the first term, 2 cubed is 8, and subtracting 2 squared, or 4, gives us 4. For the second, 3 cubed is 27, and subtracting 3 squared, 9, gives us 18. This n cubed minus n squared pattern continues. 64 minus 16 is 48. 125 minus 25 is 100. For the final number, 6 cubed, or 216, minus 6 squared, or 36, gives us 180. Recognizing the proximity of these numbers to standard squares and cubes allows you to identify the structural formula without doing trial and error addition. The third framework is for series that feature an explosive leap in scale, specifically between the final 2 visible terms. Look at the scale shift in question 18, 3, 6, 18, and then a massive jump to 108. Massive jumps like this usually indicate that the sequence terms themselves are being used as the multipliers for the next value. Multiplying the first term, 3, by the second term, 6, produces the third term, 18. Applying that logic to the end of the sequence, 18 times 108 gives us the final answer, 1,944. Looking at the scale of the final jump before performing any calculations prevents you from wasting time on the wrong mathematical strategy. Our final framework deals with questions that ask you to find the rule breaker hiding inside a completed sequence. Question 47 presents 7 numbers: 2, 5, 10, 17, 28, 40, 58. To find the outlier, we extract the pattern from the earliest numbers. 2 to 5 is plus 3, 5 to 10 is plus 5, 10 to 17 is plus 7. This establishes a clear odd number addition rule. When we project that pattern forward, the next jump must be plus 9. That means the next term should be 26. The sequence provides 28 instead of 26, identifying it as the pattern breaker. In wrong-term questions, you must confidently project the initial pattern to expose the imposter before the clock runs out. These 4 frameworks cover the most common series types: double differences, hidden cubes, term multipliers, and pattern breakers. Now we want to see if you can apply these rules in real time. Look at question 30, 7, 24, 58, 126. Identify which framework applies, solve the sequence, and share your answer in the comments. We'll pin the first correct breakdown we see. Mastering these 4 frameworks replaces guessing with a precise, systematic, and lightning-fast process for every problem.